This is James. You can also call me Ing Wei. The title of my session is Honey, Python Inside Android is Under Control. First of all, let me introduce myself. Of course, you know that my name is James, and I am the chair for PyCon Malaysia 2019. I'm also the co-chair for PyCon Malaysia 2018. And also, I'm a senior automation engineer in one of the leading industrial insurance company, where my job is my daily job is to deal with the network automations and discovery for network devices in the company. Just a small information about PyCon Malaysia. Currently, PyCon Malaysia has about 100 100 people of the community. So we are quite a small community at time, but right now our growth rate has been quite steadily increased. We have also hosted PyCon APAC Malaysia, PyCon APAC 2020 online. Even though the hosting is quite difficult, but I think at the time that this has been recorded, I believe that we have hosted a very successful event. Now, before we talk about the ideas of the Android phone, let's just look at how things has been developed over 20 years. On the left, it was the computer that I had when I was 15 years old. It was 4A6DX4 with the CPU speed about 100 megahertz. The RAM is 8 MB. And if you look at the size and the OS has been loaded compared to today, sadly, you might say that this is very sad and this is, it can't do much during the time. But that was the computer that I had during the time when I was 15 years old compared to the current phone that I have right now. Current phone that I have right now, I have the RAM which is more than 2 gigabyte, which is about 8 gigabyte, and the hard disk size is about more than 8 gigabyte. Probably we have more than 16, and the size compared to it is about a pocket size. Okay, and though even though it runs on the Android or iOS, but the OS that owns by our phone runs much more powerful than what I had 15 years ago, which is those 6.22. Because the OS nowadays is a 64 bits of the operating system. Meanwhile, 20 years back, I have only 16 bits of operating system, which is those 6.22. So our Android phone nowadays is not just a phone. It is also a computer, and it loads with a lot of sensors. And these sensors help us to track a lot of things. For example, our locations, the accelerometers, and then some of them also equipped with NFC and a lot of different kinds of apps that acts as a tracker to track not just our location, also our health and everything. But even though this Android phone is very powerful nowadays, we find that the phones will be degraded on average of 2 years, meaning that we need to change the phone over 2 years. So if you look at the life cycle of your phone, you find that every 2 years, you're going to have a new phone. So what are we going to do with the old phones then? So the possibility of some the old phones will be either we'll throw it away after 2 years, or probably we'll just keep it somewhere that we no longer see, or probably we'll just use it for the sake of other apps. Like I heard about that some people will use a particular GPS apps on the old Android phone. Or perhaps we'll give the phones to our parents who is not quite who is not quite good in using the tech. And probably the last options will be what as developers or programmers will say, can we program it? Okay, so in this case, when we talk about programming, of course, we have a lot of options. Like we do have a Java, we do have Kotlin, and not to mention that some of the latest software, which is like Flutter and all that, we can definitely program that. But somehow having a program on the Android phone is not straightforward. And to me, all these languages are difficult to learn in the sense that it has quite a big challenge in terms of the learning step. So this is this is what this talk about, because what I'm thinking doing in this project over here is try to run Python on Android phone. And what I got as a feedback of that is people will say, well, you definitely can run a Python on Android phone, but are you able to interact with the sensors? Meaning that, let's say if we want to use a location, are we able to attract or receive the GPS location from the Android phone? So that is the question that I have. Fortunately, I'll say yes throughout my project, and the Python running on the Android can do far more things that we can think of. So this is what the talks is about. And also this is also the motivation of this project over here. Now, what started the motivation of this project is I still like my old phones, which is having a very large RAM, which is about 4 gigabytes of RAM, even though it has been I have used it for 2 years, which is about in what we mentioned just now is kind of old, but it's still running fast. So I would like to keep this phone and learn how to write a Python programming on this phone over there. So I decided to run a project called project for this, which I would like to run a simple barcode scanner, because barcode scanner seems to be quite expensive back in 4 years time. So I decided to say, okay, is it possible for us to just run a very simple Python code that allows me to interact with the camera on the Android phone so that it can be used as a barcode scanner. So I decided to look for Google, okay? And this is what I got from Google. So turn out Google is always your best friend, so do utilize that. So the first search that I have over there is Android barcode scanner in 6 lines of Python code. That turned out to be interesting. And digging further, we find that the code is really easy. What I need to do is I just need to import the library, import Android, and I just need to call the method. Then I can scan the book, scan the barcode of the book, and I can get the information of the book. So this project has helped me a lot because I have quite numbers of books, about 500 books at home. So cataloging the books has always been a very painful job for me. So with this barcode scanner, through using the Python, it will help me. It definitely help me to catalog my book easily without going to enter the information about the book one by one. So question over that, yes, can we actually run or access the sensors on the phone using Python? The answer is yes, but how can we do that? So after that project, I decided to dig further and see what has offer in Python on the Android phone. Okay, so what I found out from that is, of course, there are a few Python apps has been written, but most of it can only run Python interpreter, meaning that there's not much Python app that can access the sensors on the phone. So after a very long search, I found out that there's one app that allows me to do that. Okay, so that will be the app that I'll review at the end of the slide from there. So the first thing that I would like to explore further on the Python over there is, okay, since every phone has accelerometer, meaning that the sensors that measures the gravity. So this is a very simple code that I write for the Python on Android. First thing, just get the gravity, so I'll record the time. And after 120 seconds, which is 2 minutes later, I'll try to read the values of that. So if you look at the code carefully, that actually will read the gravitational field from 3 different axes, X, Y, and Z, and then I'll do an average over that. So that will give me the value of the G. So it is a very simple app that I can write using Python on Android. But that does not stop me to go further because I would like to know more about what happens at the back end of this Python or Android. So I begin to look at that. Few questions over here. How does the Python access Android API? How accurate is the data that returns from the API? And throughout the diggings of this question over there, there's two files that I found it from their repository, which is one Android helper.py and another one is android.py. Okay, this is a small snippet of the code for Android helper.py. So they have different kinds of methods over there. And of course, we would like to focus on one method that we are very familiar with, which is scan barcode. So throughout the reading of the code for scan barcode, we realize that there's one part of a very interesting method over there, which is a private method in this context, which is RPC scan barcode. So does it mean that Python code actually interacts with Android API via RPC? Okay, that's the first question. And the second question is, if RPC has been used, how does it interact with the indent or Android API? So since we mentioned that there are second files that we look at, which is android.py, then we'll begin to look at that for android.py. So for the structures of android.py, the class Android is very simple. First thing, you initiate the Android object or instance in this case, and then you forms a self-socket connection. So this socket connections will connect to its own local host, and then you use the JSON data to write the data to the API, to the Android API via the RPC method. So if you look at the RPC method over there, you find that there's a change. The data is being encrypted. The data is being changed to JSON format, and it will send the data to the Android API via the socket easily. So once the socket has received and processed the data, you return the result object over here. So it is quite simple for us to know how things work at the back end over there. So as a summary, not summary here. So on the Android end, what happens is Android will receive it via the RPC again, and you process it according to the call's indent and returns the result as what we have seen over here as a return of the result. So to summarize that, what we see over there is when we write a Python script over there, first thing we have to import the android.helper. And once this android.helper has been called, it will send the request through to the Android. So android.py over here, we process the request and process the request and send the JSON data to the indent via the localhost socket. The Android indents receive the request, then it will process and it reads the data from the designated sensors. For example, in this case, when android.py receive a request for scan barcode, it will process and send it through the Android via the RPC and then opens out the camera. The camera will scan the barcode and process the data from the barcode and send the data back to Android indent, then to the Android and back to the Android helper, and hence our script over there are able to read the data from the barcode. So this is something that is quite straightforward without that. And looking at it, the API itself, it is very elegant in a way that it is simple and it does the job that it needs to be done. So these are the APIs that currently can be accessed, which is first thing, as I keep mentioning, accelerometer, and we do have a gyroscope. In terms of, in this word, some of you prefer to call it orientation. And we do have location, and we can access Wi-Fi, Bluetooth, SMS, phone calls, and everything. However, there's few versions that you can find for this Python or Android. First thing, if you're downloading from the Play Store, you might have a limited privilege. But if you download it from GitHub, then you have more access to different kinds of the indent or sensors on the phone. So as I mentioned before, there's a few apps that you can use rather than few other kinds of apps that you have on the Google Play Store. These are the two apps that I will recommend for you to play with, particularly for the QPython 3, because these are the app that allows you not just to write a simple Python script for the latest version, it allows you to run the NumPy, SciPy, Scikit, as well as the Keras together with Android.py, as we mentioned before. So this is something that worth for you to try out. And not to mention that this is an open source app, meaning that if you know Java, you can contribute your Java code to this project. So purely this is an open source project over there. Okay, so right now we have a demo time. So these are the demos. For the first demo, we'd like to do a location tracking. And for this demo over there is a demo that shows how we can read the data straight away from the phone and display it with a leaflet via the Flash applications.
The purpose of this recording is to show how the location tracking web app works using the WebSocket from the Python on Android. So from this app over here, what we can see is the web app that we written in Flash connect to the WebSocket, which is the IP address of the WebSocket server on the Python on Android app, while the front end is written using the Vue.js together with the leaflet map app. So as you can see, this is the code that we have over there where we connect to the WebSocket and then we display it. So this is a web app that we see from that. So it can get the current location as what we have seen over here, as well as getting the real-time GPS feed. So right now we can get it the feed. So just wait for a while. Okay, just try to refresh that so that we get the location. So get the location and then we'll get the feed. So right now this feed is a little bit off because right now I'm actually at the location where it has quite a bad poor internet connection. So you'll get the approximate location for that. So it will have a little bit of deviation for that. So meanwhile, in this recording, I'm going to record down the location of this GPS live feed for a good 10 minutes. Okay, as you can see, I have stopped somewhere right now to finish the recording. So if you look at the trace, it actually shows the driving that I have at each point. So if you click on all this point over there, it shows you the time where I drive, how I drive, and then where the time. So this drive over there also shows the speed of the location that I'm at, as well as the plot. So this is clearly a very good demo to show how I can track the driving of myself as well as other tools by using just a very simple Python on Android app. Hope you enjoy it. Thank you.
So this is the demo for the location tracking. Now we'd like to look at another very fun demo as well that we utilize the phone call. So in most of the data center or for SRE, we do have a problem with the what we call as surf one, or somebody calls that P1. Okay, meaning that you have the severity one, meaning that you have an incident that is really down, or you have some sort of utilization which goes beyond your critical level, which you need to address that. So what happens in this demo over there is I'll generate a random number to simulate the utilization of the CPU. So when the CPU usage is more than 80%, I'll make my phone to call the SRE. So in this demo over there, I used a few ingredients over there, which is the ZMQ. In this case, ZMQ is just zero message queuing together with simulated CPU utilization tools, okay, and also the Android call. So I would like to begin my demo over there. The purpose of this demo over here is to show that we can use Python on Android to write a simple call script when we are having an issue in the data center. For example, in this demo over here, we use the case of when the CPU is hitting a percentage of 19%, the script will make a phone call to the respective SRE. So in this script over here, this script actually is a very simple script that allows me to send the incident by using a random number generator. So first, in this case, I'm going to generate the status of the CPU by using a random number from 0 to 100. So if the CPU is hitting 80%, we'll record the time and then it starts sending a string of 1 to the respective ZMQ on the IP address, which is as the following over here. If the CPU is below 80%, then we'll send a string of 0 over here. So 1 over here will represent the incident is happening, which is the status that the CPU is hitting a percentage of 80%, while 0 is not is below 80%. So for every 5 seconds, we'll check, and if there's a incidence over there, we are going to send this across. So right now, I'm going to start with the script that I have. What I'll do right now is I'll start the script for now. And here, I'm going to show you the phone. I will start a video and then I'll make a phone. So if you look at that, the screen, I have a phone over here. We are still waiting because the CPU has not reached above 80%. Okay, it starts making a call. Yep, if you hear that, that is the sound. So the phone is ringing right now. So we have successfully making a call. Okay, so right now is again, it will make a call in a short while. Let's just wait for a moment. Okay, it's going to make a call again. Okay, the phone's ringing. Okay. Yep, the phone is ringing. So, okay, so answer phone. So here comes the demo. Okay, here comes the demo. So I hope you can enjoy the demo for this script over here. Thank you. So these are the reference for the my project. If you like, or if you're interested, you can look at all this reference over there so that you can get more details on that. With that, that is my presentation, and thank you for attending my presentation. Thank you.